This lesson is going to dive even deeper into using properties of equality to solve systems of equations using the method of elimination. The previous lesson kind of introduced this idea, and today we're just going to make sure that you really understand how you can use it and practice. So here, first, we're going to solve it in two different ways. First, we're going to eliminate x, and we're going to eliminate y. We're going to do that to show that it doesn't matter which one you eliminate first, as long as you are following rules or properties of equality. So to eliminate x, I need the 4 and the -2 to either be the same number or the opposite. So I know that I can multiply -2 times 2 to get 4. So I'm going to take this and multiply it by 2 so that my coefficients are now the same number. Right? Because if it's the same, I subtract. If it's opposite, I add. So same, subtract, opposite, add. So here I'm going to add to eliminate my x. Oops, I forgot to multiply. All right, so now I have 7y equals 28, so y equals 4. Now I can solve for y. So 4x plus 5 times 4 must equal 12. Or x equals -8, so x equals -2. So my first solution here is -2, 4. All right, now I'm going to eliminate to solve y. So here I have a 5 and I have a y. So now I'm going to multiply this second equation by 5. Bring down my original. Here I have the same, so I'm going to subtract. So -10x minus 4x gives me -14x, 0y. 40 minus 12 is going to be 28. So -14x equals 28, and x equals -2. So I already showed that if x is -2, y is going to be 4. I need to justify that it also works for my second equation here. So if I have -2 times -2 plus 4, I proved that it is a solution because here, right, I found that it works for the first value. Here, I got the same one, so it didn't matter which one I eliminate first. I was able to find the solution because there's the same solution no matter what. Okay, let's take a look at this one here. So here I have 5x minus 2y equals 10, and 2x plus 7y equals 43. So here, you can eliminate x or y first, it doesn't matter. I see that these are both positive. Here I have a negative and a positive. So I guess it just depends on if you want to add or if you want to subtract. If you want to add, then the opposites should be the same. If you want to subtract, then the same ones should be the same. I am going to add. So I'm going to multiply my top equation by 7 and the bottom equation by 2. So this one will become 35x minus 14y equals 70. And my second equation becomes 4x plus 14y equals 86. And now I'm going to add together, so 39x plus 0y equals 156. 39x equals 156. And I get that x is equal to 4. Now, to solve for y and then to check, I'm going to use my original equations. Again, just like up here at the first one, I had actually made a mistake originally and not distributed the 2. So that could have messed it up if I hadn't checked it and seen it before I continued working through the problem. So to make sure I didn't make any errors, I'm going to use my original equations now to solve for y and to check. So 5x minus 2y equals 10. X is 4. So 5 times 4 negative 2y equals negative 10. Y equals 5. And then I'm going to check with this 2x equation. So 2x plus 7y equals 43. And I am checking for 4, 5. So I get that 8, let me go for a little bit here, plus 35, and it works. If you had solved the other way, you would have also gotten the solution of 4, 5 if you had eliminated the x variable first and then solved for y. All right, let's look at some applications. So we have 2 lines that pass through the points -2, -11, and 3, 14. We want to find the equation. So substitute both of the known points in to create a systems of equations with a parameter of m and b. So remember, we have x, y, x, y. So I'm going to have -11 equals -2m plus b, and then 14 equals 3m plus b. Now I will solve and write the equation. So I have the same sign here, so I'm going to subtract. -11 minus 14 is -25. -2 minus 3 is -5. And then my b gets eliminated. So m is equal to 5. Now I can solve for b. So -11, -11, that's why you don't use pen, you use pencils, you can erase. So -11 equals -2 times 5 plus b. So b is equal to -1. Let's check, does it work for the other one? So 14, does that equal 3 times 5 plus -1? It does, so the equation is that y is equal to 5x minus 1. So that's a way that you can use a system to write the equation of a line if we know the 2 points. Another way would be to find the slope and then substitute into point slope form and then simplify and rewrite into slope intercept form. Many different ways. All right, here, can we find the equation of the linear function? All right, yeah, but we're going to be doing that by, again, using our x and our y values. So I know that 3 equals -2m plus b. I can use any of them, and then I'll use the 9. 9 equals 10m plus b. It doesn't matter which ones you use because you'll end up with the same relationship. All right, I'm going to subtract these. So -6 is equal to -12m. So m is equal to 1/2. So 3 equals -2 times 1/2 plus b. So b should equal 4. So my equation should be that y is equal to 1/2 x plus 4. And you can check it with the other ones. So 1/2 times 2 plus 4 is 1 plus 4 is 5. So this one checks. And 1/2 times 6 is 3 plus 4, which is 7. So this one checks. So this is the equation of the line. All right. The next lesson is going to deal a lot with modeling real-world scenarios, but this is just kind of a little one to get you to practice. So two numbers have the following properties. The sum of the larger and twice the smaller is equal to 13. Twice their positive difference is equal to 8. What are the two numbers? So how can we model the problems? And we need to be really careful in determining what our variables should be. So I'm going to say let x equal the smaller number and let y equal the larger number. So because they use those terms, smaller and larger, that is how I'm going to refer to them. So the sum of the larger and twice the smaller is equal to 13. So the sum of the larger and twice the smaller is equal to 13. Twice their positive difference, so a positive difference means we want the larger minus the smaller, is equal to 8. So we should be able to then use this to solve. So let's see if it works. So y plus 2x equals 13. 2y minus 2x equals 8. They're opposites, so I'm going to add. So 3y, these are eliminated, equals 21, so y is 7. If y is 7, then 7 plus 2x equals 13. X is equal to 3. So 7 is larger, 3 is smaller, is twice their positive difference equal to 8. Yes. So this is my system. My system is y plus 2x equals 13, and 2 times y minus x is equal to 8, but only because of how I defined my variables. If I had defined them differently, then they could have been flipped, but the smaller number would always be 3, and the larger number is always going to be 7, but you could end up with x is 7 and y is 3 if you defined them the opposite way.